We're still on lesson 11.2. Now the second part is rationalizing the denominator. What does rationalize the denominator mean? It means get rid of the root or the radical from the denominator. Usually, there is only one way for us to get rid of the denominator. The first example is 5 over radical 2. How do I get rid of the radical 2? I take my denominator and I multiply the numerator with the denominator. So I multiply with a fraction made up of my denominator times radical 2 over radical 2. And I simply multiply. 5 times radical 2 is 5 radical 2 over radical 2 times radical 2 is actually radical 4. Now I start looking at how I'm going to simplify. Can I simplify radical 2? It's already a prime. I cannot simplify it anymore. 5 radical 2 over radical 4 is actually a perfect square, which is 2. And that's my answer. Sometimes if I can simplify the numbers or the whole numbers outside in my example, I do simplify them. If I can't, I don't touch anything inside the radical. The second example is 2 radical 3 over radical 3. I take my denominator, I multiply it to my numerator and my denominator. And now I start multiplying. 2 radical 3 times radical 3 is a radical 9 over radical 3 times radical 3 again is a radical 9. A radical 9 is a perfect square. It gives me a 3. So it is 2 times 3 over radical 9 again is a 3. And my answer is 6 over 3. So, and I can divide them. I can simplify them. My answer is 2. The third example is 5 over radical 7. Again, I take my denominator. I multiply by radical 7 over radical 7. 5 times a radical 7 is 5 radical 7 over radical 7 times a radical 7 is a radical 49. Again, this is a perfect square, which is actually a 7. Can I factorize radical 7? I can't. It's a prime number. So my answer is 5 radical 7 over 7. Can I simplify 5 and 7? I can't, so I leave my answer as it is. Always remember, I cannot have a radical in my denominator. I cannot have a fraction in my radical. And my radical cannot have perfect squares in the answer. So this is one of the cases that I have a fraction and I need to get rid of it. First of all, I need to split this. What does this mean? A radical 13 over a radical 100. I split them up into two parts, each one differently. Can I factorize a radical 100? It's a perfect square. It's actually a 10. 13 is prime. I cannot split it, so it's actually radical 13 over 10, and that's my answer. A radical 7 over x to the second power. Again, it's a fraction. I have to split it up. It's actually a radical 7 over a radical x to the second power. Can I open up a radical 7? Can I find perfect squares in it? Can I simplify it? No, I can't. It's prime. Can I radicalize x to the second? Yes. The square goes with the radical. So my answer is radical 7 over x. And that's my final answer. 3 over radical 2x. I have a radical in my denominator. How do I get rid of it? How do I rationalize it? I multiply with a radical 2x over a radical 2x. 3 times a radical 2x is actually 3 radical 2x. I cannot multiply a whole number with a radical. They're both different. Over radical 2x times 2x. 2 times 2 is radical 4. X times x is an x to the second power. 3 is already a whole number. Can I open up radical 2? No, it's prime. Can I open up a radical x? No, I can't because I need to work in pairs and there are no pairs here. So my numerator remains as it is. What happens to my denominator? If I need to look at my denominator, radical 4x to the second is actually a radical 4 and a radical x to the second. Radical 4 is a 2. X to the second, the square goes with the radical. X is left, so it's 2x. So my answer is 3 radical 2x over 2x. I cannot simplify radical 2x with 2x because this is a radical, this is not. I cannot simplify the 3 and the 2, so I leave them as they are. Our last example is a fraction inside my radical. The first thing I do is I split them. Radical 8 over radical 3n to the third. What do I do for me to rationalize? I multiply with radical 3n to the third times radical 3n to the third times radical 3n to the third. I start multiplying. This is a radical and this is a radical, so it's actually 24 n to the third over 3 times 3 is 9, n3, and n3 is n to the sixth, again, a radical. Now what am I going to do? I'm going to work on my numerator on its own and my denominator on its own. Radical 24n to the third. Always remember, work with pairs. Radical 24, radical n to the second, radical n. Radical 24 is actually, look for your perfect squares, it's radical 4 times radical 6. N to the second is already done for me, and now I start opening it up. Radical 4 is a 2. Radical 6 is 2 times 3, both are prime. I circle it, I cannot change it. Radical n to the second, the square goes with the radical, n is left. Radical n is 1, so I cannot touch it. It stays as it is. What's my final answer here? It's 2n radical 6n. I write it down in my numerator. 2n radical 6n over. Now, what about my denominator? My denominator is radical 9n to the sixth, which is made up of radical 9, again in pairs, n2, n2, and n2. Now what do? Radical 9 is a 3, n to the second, it's an n to the second is an n to the second is an n. So my answer is 3, 1, 2, 3, n to the third. So my answer in my denominator is 3n to the third. Can I simplify 2 and 3? I can, but my n's are common. So I have 1 at the top and 3 at the bottom. N times n times n. I cancel off one of them. How many are left? N to the second as a denominator. So my answer is 2 radical 6n over 3n to the second. I cannot simplify what's in my radical with a whole number that's outside. As a wrap up, let's go back to the basics. First of all, I always have to simplify using perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and so on. This is very important. Next, I cannot have fractions in my radicals. I cannot have a denominator of a radical. These three rules are always applicable in all the radical expressions. The first part was simplifying to the maximum, reaching to a point when you have only prime numbers inside your radicals. The second part was rationalizing the denominator. When you have a radical in the denominator, what do you do to get rid of it? You need to get rid of it. It's not allowed as a rule. So you multiply the numerator and the denominator with the denominator itself, and then you start simplifying. Always remember, you're working for the variables in pairs. In numbers, you're working with perfect squares. This is the whole thing about the lesson.